Hello everyone. Welcome to the channel. I'm here with another video. Actually, today what I'm gonna do is I'm gonna do two packet tracers. They're pretty much similar. Okay, so I'm gonna start with this one. As you can see, this is packet tracer who hears the broadcast. Okay, and we're gonna talk about VLAN. Okay, and what is VLAN and what's special about VLANs, right? And why do we need VLANs in the networking area? Okay, so if you are a network administrator, you probably already know about this stuff, but those of you who are trying to get into the networking field, you need to know this stuff. Okay, you need to understand the theory behind VLANs, and then how it works. Okay, and it's really important. Once you grab the knowledge on VLANs, it it just it helps you tremendously when you are organizing, where you're when you are arranging a lot of end devices, right? So let me give you one quick example, right? Why VLANs is important to the networking field, right? So basically, let's say you are in charge of a very large conference room, right? You need to arrange, and then you have multiple experts, right? Multiple, let's say, presenters. They're coming at the same time with their smaller audience, right? And then you have this big room now where all the experts, are in the same room, and then they have their own smaller audience in that same room. As you can imagine, right? All the people, when all those experts are speaking at the same time, it's gonna be really noisy, and the smaller audience, the groups, they won't be able to hear their expert clearly, or there will be a lot of confusion because all the experts are speaking at the same time, and it's distracting everyone, right? So there's like a chaotic situation. So to resolve that, what do you need to do? To resolve that, that's where the VLANs kicks in, right? That's where we need the VLANs, and that's what VLANs allow us to resolve that type of traffic in the networking. So if you have, now what you can do is uh, you can assign, right, each group with their own smaller room. Okay, so now each group can have their own space, their own room where they can present, and without being distracted or without distracting the other person, right? So that's where the VLAN works. That's where VLAN lets you do that, to segment your network. So that way, it works. Each VLAN works independently with their own networking. Okay, even though they share the common infrastructure. For example, let's see this one, right? The one that I'm showing you right now. So they're all, so we have almost from zero to almost 23 end devices. Okay, and but they're all connected to the same switch. It's the same common infrastructure, right? But however, you as you can see that, so this group 15 to 8 has their own VLAN, which is VLAN 10. So they have their own separate room where they can work with each other. Okay, now as you can see, this group right here, they also are working under VLAN 30. So they have their own room, own space, without being distracted from VLAN 10 or VLAN 20. Now they each can work independently with their own groups. Okay, and this will improve your network. This will improve the speed. This will reduce from having multiple devices, which is really cost effective, right? It saves a lot of. So basically, we call this is a logical connection, right? Logical connection, right? And your physical connection, you have one physical connection, right? But these multiples, these are logical connection because they're all virtual LANs, VLANs, right? Um, so that's the beauty of implementing VLANs. Okay, so without any further ado, let's jump into this chapter, okay? And then let's get going with this chapter. And I hope you understood a little bit about VLAN, and you can always, do your own research and do your own homework, and you can deeply understand what VLANs is, and it will tremendously expand your knowledge and helps you better to become a better network technicians. Okay, all right. So moving on to the lab here. So first, what we're gonna do is objectives. Part one: observe broadcast traffic in a VLAN implementation. Okay, all right. So we're gonna observe broadcast traffic. Okay, and then the step two, complete review questions, and then we're gonna complete the questions as well. Okay, so all right, so let me bring up actually what we're gonna do here is okay, so in this activity, a, a 24 port Catalyst 2960 switch is fully populated. Okay, this is all fully populated, and that's the 2960 switch. Okay, that's good. So everything's been all set up, all ready to go. We just need to observe the traffic and just review some things here. Okay, so step instructions. Step one: use ping to generate traffic. Okay, so you can do I think couple of you can do this in a couple of ways. Okay, first, I'll show you the um, let me show you the oh, that's sorry. Okay, um, one that's they're saying here. Okay, you can go to PCO and go over to desktop and then command prompt. You can also ping right here. Okay, if you just type in ping, what's the IP address? 92.168 dot 1.8. Okay, so it should ping, but sometime I don't know, this doesn't work. It takes a minute or two. Let's if it doesn't work, we can but as you can see that while I was working on this packet tracer, it was pinging, right? It was pinging just fine. Oh, you know what? I think that's a 68. I put 58. That's why it's thinking. But anyway, that's how you do it. And if you get the reply this, that means it's pinging. It's good to go. Okay. And let me show you something quickly. Something. This ping right here. So we know that this 3.192.168.1, that's your network ID, right? And then so in this VLAN 30, they all gonna have they all gonna have same network ID. Okay, okay, because it's in the same network. Okay, and then the last one 8 is that's your device. Okay, that's your account. Okay, the 8 means, so I'm assuming it's gonna be PC7, because we already have this. So we're gonna count like this. We're gonna count from 0. 0 gonna be a 1. Okay, so we're gonna count 1 0 as 1. Okay, so if you 1 2 3 4 5 6 7 8, so if you go here, go to IP config, it should match the IP address. So there you go, see that? So we were basically pinging this device from PC O1. Okay, I'm gonna do, I'm gonna delete that packet. Let's the other way you can also do is, if you go over here, okay, that's your simple PDU uh, packet, and then if you click here now and then click to all right, so we want to send this over there and here. Okay, I'm actually okay, so let's do that, and then if you hit capture then forward. Okay, we want to forward that packet there. Okay, it goes to the switch. Now again, hit it again, goes to the PC7, but this is actually technically it should be PC8, but because the PC0, um, that's it counts as one. Okay, so that's why. Okay, it's still in progress. Let's hit it again. Okay, hit successful, right? We were able to send the packet to that, and then it received the packet and it sent back to us saying good. All right, everything's good to go. Is it pinged, right? Okay, now we're gonna do similar. Okay, so that's how you can ping the other way. Okay, instead of going to the CLI or command prompt, you can do that way. Okay, all right, so we're done with this actually. Let's move to step 2. Generate and examine broadcast traffic in a VLAN implementation. Okay, all right, so let's do this. I'm gonna drag this a little bit here. Okay, switch to simulation mode. Okay, so let's go. We're already in this, so I just want to show you how did I get this. Go right here, simulation. Oh, what's going on now? It's not. Okay, yeah, simulate view event list, that's the one. Okay, and then you want to click edit filters. Right now there's nothing selected. Sometime you'll have like this. Okay, if you have like this, you can just click that again and it will uncheck everything, because we want to uncheck, right? It says um, go and uncheck the show all or none checkbox and just check the ICMP. Okay, and the ICMP packet is for your ping uh, feature. Okay, that's your ping packet. All right, so we're gonna close that one and then click the add complex PDU tool. This is the open envelope icon on the right toolbar. Okay, right toolbar, if you float here, and then it will pop up that name right there, add complex PDU. Okay, so you click that, and if you float the mouse over the topology, and pointer changes to an envelope with a plus sign. Okay, there you go. Yep. Okay, yep, there you go, there's a plus sign and the envelope. Okay, now click PCO to serve as the source for this test message, and then create complex PDU dialog windows opens. Enter the following values. Okay, so if I click PC0, all right, so here you go, the dialog window opens. Now let's go ahead and put the destination IP address, which is going to be 255.255.255.255. All right, and then the sequence number going to be 1, and then one shot time, that's 0, and then create PDU, hit that PDU. Okay, so we created that. Now, so let's answer. It says within the PDU settings, okay, right here, within the PDU settings, the default for select application is ping. Okay, yes, that is true. Let me see here. Let me go back. Okay, I think let's do this. I'm gonna delete this. If you want to delete that packet, you can delete that. Let's redo this because I want to answer. All right. So what are at least 3 other applications available for use? Okay, this is what it's talking about. Okay, select applications. So these ping is the default application, and you have DNS, FTP, HTTP, all this packets, okay, are available. So you can write all this, or you can just write 3. Okay, choose from them. Okay, that's what I wanted to show you, but let's put the destination IP address. Okay, sequence number 1 is 0. All right, so okay, and okay, and then click create. Let's create. All right, now appears in the simulation panel, event list. Okay, it also appears in the list window. Okay. And then it is the first PDU for scenario 0. Okay, that's the first PDU. That's the first PDU right there. Okay, now click capture and forward twice. Okay, click once. See, as you can see, the animation right here, the packet moves to, that's your switch. All right, and then if you click again, it forwards that packet to all PCs, all devices in the VLAN 30 network. See that? It didn't forward it to VLAN 10 or VLAN 20. I think we're going to talk about that down right here. So, okay. So that's good. And what happened to the packet? All right. What happened to the packet? So the packet is sent to the switch, right? Then broadcast to all of the PCs, right? And that belong to the same VLAN, in this case VLAN 10. Okay, that's what happened basically. All right, so let's repeat this process for PC 8 and PC 16. All right, so what we're gonna do is we're gonna click new. Okay, scenario number 1, and for it, okay, sometime you have to go exit out of it and then click back in, and then what you do is click 8.255.255.255.255. Okay, and then still gonna be sequence number 1 times 0. Create PDU. All right, and then we're gonna hit 1, goes to the switch, hit again. Now it broadcast to all of the PCs that belong to the same VLAN. Okay, that's good. All right, now let's create another one, another PDU. All right, hit new again. All right, now let's do 16. Okay, you have to hit it again. 16 on 255.255.255.255. Okay, and then it's gonna be sequence number 1, 0, create. All right, now click, goes to the switch, and then switch forwards the packet to all the PCs that belong to the same VLAN. Okay, that is awesome. Okay, so now we're done with the lab here, but we're gonna answer these questions. Okay, let's reflect. Let's do the reflection questions. All right. Okay, so number 1: if a PC in VLAN 10 sends a broadcast message, which devices receive it? All N devices on VLAN 10. That's your answer. Okay. And number 2: if a PC in a VLAN 20 sends a broadcast message, which devices receive it? all end devices. Okay, this is your all end devices. Um, all end devices on VLAN 20 will receive the broadcast message. Okay. Number and then number three is also same. All not same, but all end devices on VLAN 30 will receive the broadcast message. Okay. Number four, what happens to a frame sent from a PC in VLAN 10? Okay, sent from the VLAN 10 um, and sent to a PC in a VLAN 10 to a PC in VLAN 30. So what happens? Um, I can show you. Let me show you a quick example. Okay, I'm just gonna do simple PDU. Let's do. All right. The question says, what happens to a frame sent from a PC in VLAN 10? Okay, let's pick. Let's create new. Okay, let's pick PC 8, which is in VLAN 10. Okay. All right. Click that, and then we wanna send that to a PC in VLAN 30. Okay, and let's just pick PC 7, right? That's in VLAN 30, right? So they're on different VLANs. Okay, all right, click there. All right, now let's do click this one once. Nice. Yeah, it's not doing anything. It should fail. There you go. See, it it didn't recognize it's out of the VLAN, right? It's a different VLAN, so it's out of the group. So the switch does not have that capability, that feature to send the packet to a different VLAN, to different group, from take it from one group and send it to a different group, because this is a layer 2 switch. Okay, so layer 2 switch does not have the capability or that function to send the packet from one group to another group. Okay, only a layer 3, either you need to have a layer 3 switch or a router. Okay, they will be able to do those function for you. Okay, now this is what I'm talking. So what happened? The packet, so basically it will drop, it will be dropped because they're not on the same VLAN. Okay, that's your answer. Number 5, which ports on the switch light up if a PC connected to port 11 sends a unicast message to a PC connected to port 13? So a unicast message is 1 to 1, right? You're sending from one device to another device. It's like a one-on-one connection, right? Whereas the multicast is one to multiple, right? One to multiple PCs. All right. So the answer for this is ports 11 and 13 will light up only. All right. And number 6, which ports on the switch light up if a PC connected to a port 2 sends a unicast message to a PC connected to port 23? So the packet will be dropped because they're not in the same VLAN. Okay, again, if it's out of its range, or if it's out of its VLAN group, it will drop the packet. Okay, so the packet will be dropped. Number 7, in terms of ports, what are the collision domains on the switch? So basically each port is its own collision domain. Okay, that's your answer. In terms of ports, what are the broadcast domains on the switch? So each VLAN is its own broadcast domain. Okay, so each VLAN is its own broadcast domain. right? Okay, and that's it for this lab. I want to make sure where we at. Um, okay, so let's do another one. Yeah, we're done with who hears the broadcast. Um, and I'm gonna close this one out. No, I'm gonna bring up the other one that I have here. So this is the other one, which is to investigate a VLAN implementation. Okay. So everything has been set up. So in this chapter, we're basically gonna do the kind of similar stuff that we did for the previous one. Because as you can see here, so the objectives is observe broadcast traffic in a VLAN implementation, and then observe broadcast traffic without VLANs. Okay, all right, so let's do this. All right, let's do this guy. All right, so step one, ping from PC1 to PC6. Wait, okay, A, wait for all the link lights up to green, turn to green. To escalate this process, click fast forward time, located in the bottom toolbar, right here, I guess. Okay, now click the simulation tab and use the add simple PDU tool. Okay, that's already clicked it here. Just use view event list, and then what we're gonna do is use the now PC1. Okay, our PC1 is right here. So what's going on right here? Okay, the topology. So basically you have 1, 2, 3 switches, and they have their, and then they are connected, right? So they are connected to each other, except this one right here has, this is the point. Okay, the main point for this switch 2 and switch 3, that's the middle switch number 1. And then we're gonna add simple PDU. All right, click PC1 and then click PC6, which is PC6 is located right here. Okay, PC6 is right here. That's a PC6. Yep. Okay, and then click the capture forward button to step through the process. Observe the ARP request as they traverse the network. When the full when the buffer full window appears, click the view previous events button. Okay, all right, so click this. It goes to our switch. All right, and from the switch goes to switch number 1, and then goes to switch number 3, and again goes to, it drops, right? So as you can see here, what happened, it failed. It didn't, packet was dropped. It wasn't successful. So if to answer the question, that's were the pings successful, explain. All right, no, the pings were not successful because PC1 is on a different VLAN than PC6, which won't allow these devices to communicate with each other because they are separated logically. That should be your answer. Okay, they are separated logically, like we already talked about it. If they're not in the same VLAN network, the packet will be dropped. So it was not successful. All right. Okay, now it says, look at the simulation panel. Where did switch 3, that's your switch 3, send the packet after receiving it? Okay, interesting. So let's go see switch 3, right there. And then, so looks like what happened is that switch 3 sent it to PC4 because it was on the same VLAN as PC1. Okay, so that makes total sense because they are on the same VLAN. The switch 3 forwarded to PC4. Okay, now, all right. And there's another question. It says when the packet reached, as you also probably saw, when it reached switch 1, it forwarded to PC7, right? It forwarded to PC7. And why does it also forward the packet to PC7? Because again, they are on the same VLAN. So the switch forwarded the packet to VLAN 10 or PC7, which is on the same VLAN as PC1. Okay, so that's your question. All right, now part 2, observe broadcast traffic without VLANs. All right, let's do that without VLANs, right? Okay. All right. Let's go close this guy, real time. Okay, just click real time. And then what we're going to do is, okay, delete the start of configuration on all 3 switches. Okay, so, wow, okay, we're going to delete start of config, okay? Let's start with let's start from switch 1, okay? Go to CLI. You don't need to enter the password for this, okay? Just enable. Okay, now we're gonna do erase. Okay, erase, startup, test config. Okay, awesome. Okay, so we deleted the start of config on switch 1. Close that one. Go to switch number 2. Enable. Now let's do erase, startup, dash config. Okay, awesome. Okay, that one's good. Now go over to switch number 3. CLI, erase, startup, config. Okay, so we deleted the start of config on all 3 switches. Okay, what command is used to delete? Which is, I already did that. Okay, erase startup dash config. That's the command you have to use. Okay. And then where is the VLAN file stored in the switch? So it's gonna be like in your flash VLAN.dat data, right? It's gonna be stored there. Delete the VLAN 5 on all switches. Okay, so we're gonna delete a file, VLAN 5. Let's go to switch 1. You want to go to enable. Okay, yep. Oh, I'm already in that. Okay, in that mode. Okay, you want to delete VLAN. You're gonna be data. All right, this is gonna delete. Oops, what happened? delete delete VLAN. Okay, sure. Yep. See, this is where it's located, right there. Flash dash VLAN. Okay. Confirm. Okay. And then let's close this one out. Let's go to PC2. Let's say switch 2, not PC2. And we're gonna do delete VLAN dot. Okay, that's successful. Go to our switch number 3, delete VLAN dot. Okay. Alright, so we have successfully deleted the startup config and VLAN file stored in the switches. Okay, now step 2, reload the switches. Use the reload. Okay, now you can also, I think, what we can do is now step 2, reload the switches. Use the reload command in privilege exit mode to reset all the switches. Wait for the entire link to turn green. To accelerate the process, click that in the located below. Um, I want to show you something. If I go back here, all right, and then if I let's add simple. Let's do a PC1. Let's go to PC7. Okay, hit that. Okay, that's successful. All right, that's good. All right, this one's good. All right, what we're gonna do is all right, so close this one, go back to real time. We're gonna reload. Okay, so let's reload. um what you can do is you go here, reload. Okay, that's all we do. Takes a minute. It just takes a second. Okay, that one's done. Okay, now close this one, go back to 1. We're going to reload. Okay. Okay, let's reload this one too. Okay. Alright, so close that. Okay, now select scenario 1 from the drop down menu to return to scenario 1 from the simulation. Now click down. Okay. Okay. Alright. Yeah. Oh, I have to wait for all the link lights return to green. There you go. It's kind of taking a second. I'm waiting for this to turn. There you go, green. Okay. Okay, just type view previous event. Alright, let's do this again. Reach maximum. Okay, let's do this. Alright, let's do this again. Okay. Okay. So what we're gonna do is we're gonna delete this. Okay. We're just gonna put. Let's just do. Add this one. Okay. Actually, let's cancel this one. We're gonna do simple that, and then we want to forward it to all our devices on the same VLAN. Okay. So we know we have this guy, this guy. All right. So let's click the this one, and then if you hit click, see, click, okay, then click back. Now, so that's what it's talking about. So now you can see that the network's ready to forward your ARP and ping traffic. Okay. um, so the switch now has the MAC address. Okay, that's your ARP table. That's where you have it restores the source MAC address. So when it gets the packet second time, it knows so where it's coming from and um, where the destination MAC address is. Okay, so and what it says is that click forward. So C from is simulation mode. Click the capture and forward button to step through the process. Notice that the switch now forward the ARP request out all ports. You see that now the switch will forward all, right? It's flooded. Okay, it's flushed to all the ports except the port on the which the switch ARP request was received. um, yep, except the the port that generated the packet. Okay, it will not send that back to the generating source. Okay. So that's what it's talking about. All right, now that's good. So this is what I'm talking about, right? This is how it's the network is very efficient, and it improves network performance. All right, so that way it's not flooding, it's not getting all the packet from all everywhere. All right, you just want to send the packet to the intended recipient. All right, so let's answer these following questions. Number one, if a PC in VLAN 10 sends a broadcast message, which devices receive it? So all devices that are on VLAN 10, okay? If a PC in VLAN 10, in VLAN 20, sorry, sends a broadcast message, which devices receive it? It's going to be all devices that are on VLAN 20. Number three, if a PC in VLAN 30 sends a broadcast message, that's going to be the same, right? All the devices that are on the VLAN 30. Okay, now the number four, what happens to a frame sent from a PC in VLAN 10 to a PC in VLAN 30? We know it will be dropped because there are different VLANs, right? There are different groups. Okay. 5. In terms of ports, what are the collision domains on the switch? So each port is a separate collision domain. Okay. In terms of ports, what are the broadcast domains on the switch? They are divided by the number of VLANs in the switch. Okay. Um, so thank you again for watching the video. I think this is the end of the video, and I will catch you in the next video. Have a wonderful day. Bye bye.